Hello. In this episode, we are going to look at the method for finding square root of a number without using a calculator. After going through this video tutorial, you will be able to solve practice now 4 and exercise 1A, question number 3, parts A and B, and question number 4 yourself. So if you are asked to find the square root of 484, you should be worried. Should you? Nah, it's easy. There are just 4 steps to find the square root of a number, and those 4 steps are: first one, prime factorization; second, grouping; third step, taking square root on both sides; and fourth step, multiply to get the answer. Let's look at each step individually in detail. So if you are asked to find the square root of 484, the first step is prime factorization. Break down the number into prime factors. Write down 484 and start dividing by the smallest prime factor, which is 2. 484 when divided by 2 gives us 242. Now again 242 is divisible by 2. So divided by 2 and we get 121. Now 121 is not divisible by 2. We move to the next prime number, which is 3. 121 is not divisible by 3. So we move to the next prime number, which is 5. Again 5 is not a factor of 121. 121 doesn't come in the table of 5. So we move to the next prime number, which is 7. And 7 is also not a factor of 121. So we move to the next prime number. Which is the next prime number after 7? It is 11. So does 121 come in the table of 11? Yes. 11. 11s are 121. So 11 is divisible by 11 only. So 11 divided by 11 gives us 1. So we are done with the division part. Now write down the number in terms of product of its prime factors. 484 is equal to 2 multiplied by 2 multiplied by 11 multiplied by 11. So again I have written 484 is equal to 2 multiplied by 2 multiplied by 11 multiplied by 11. So the second step is grouping. How do we group it? First of all, we make pairs of 2 and write it in index notation. As you can see, I have written in red 2 multiplied by 2. We are going to make pairs of numbers. We are going to separate two numbers. So 2 multiplied by 2 can be written in index notation as 2 square. And 11 multiplied by 11 can be written in index notation as 11 square. Now at this point, I like to tell my students that let's suppose we are very lazy and we don't want to write this power 2 again and again with the number. So why not we write this power once? We can write this power once. How? We can rewrite these numbers by combining them in a bracket. So we can write 2 square multiplied by 11 square as 2 multiplied by 11 whole square. So we have written the power 2 once. Since power was same in both cases, so we have written the power once. And an interesting way to remember is, since we are lazy, we don't want to write the power again and again, so let's write it once. What? Breaking news? In the middle of a maths lesson? The great fight? Survival of the fittest? We can see a boxing ring and a square root sign and the number 259 and a square. So what's going on? Who is fighting? Oh, from the left, square root has entered the boxing ring. And from the right, square has entered the boxing ring. So are square root and square sign going to fight for their survival? Who is more powerful? What do you think? Who is going to win this fight? Are you as excited as I am? Let's see who will win. So they're ready to fight. Let's see who wins. Let the fight begin. Oh, they both are dead. They both have killed each other. And the numbers are very excited. Look at the numbers dancing. So when square and square root fight, they both die. They both cancel each other's effect. They both are as powerful as each other. So it means when a number has a square as well as a square root sign, they both cancel each other. They both fight with each other. They both kill each other. And what do we get? We have the number free. The number is no longer imprisoned within the square and the square root sign. So let's continue with the lesson. So we had written 484 as 2 multiplied by 11 whole square. Now the step 3 is we take square root on both sides. So we write square root on this side, and then because we have written it on one side of the is equal to sign, we are bound to write it on the other side as well. So when we have written square root on both sides, what happens? This square cancels the effect of this one, and the numbers are set free. So square root of 484 is equal to 2 multiplied by 11. So the numbers are free. They are not bound by square and square root anymore. And what is the last step? We simply multiply these numbers together to get our answer. What is 2 multiplied by 11? It is 22. So the square root of 484 is 22. So let's recap the method. First step, prime factorization. Second step, grouping into twos. And third step, taking square root on both sides. And fourth step is multiply to get the answer. You can pause the video here and go back through the method again to see if anything is not clear to you. I hope everything is clear. Let's do another example. This is worked example 4. We are asked to find the square root of 324. What is the first step? Do you remember? It is prime factorization. Prime factorization of 324. 324 divided by 2 gives us 162. 162 again divided by 2 gives us 81. 81 is not divisible by 2, so we will move to the next prime number, which is 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And then 3 divided by 3 is 1. So we can write 324 as 2 multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. Now notice here that 3 is coming 4 times. But we have to make the pairs of 2's. So 2 multiplied by 2, which can be written as 2 square. 3 multiplied by 3, which can be written as 3 square. And then again 3 multiplied by 3, which is written in yellow. So it will be written as 3 square. So while finding the square root, we group the numbers into twos. And since we now know that we are lazy and we don't want to write the power again and again, we can write it in combined form as 324 is equal to 2 multiplied by 3 multiplied by 3 whole square. Now step 3 is take square root on both sides, write down square root on both sides, and on the right side the square sign and the square root sign will cancel each other's effect. And what do we get? We get 2 multiplied by 3 multiplied by 3. And when we multiply the numbers together, 2 3s are 6 and 6 3s are 18. So the square root of 324 is equal to 18. So is the method clear? Can you do it now? Yes, you can do it now. Now you can find the square root of any perfect square using this method. This method is only applicable for the square roots of perfect squares. Now try solving the relevant questions from your book. The next video is going to be about cubes and cube roots. Stay tuned.